if n is a 3-digit positive integer, what is the 10th digit of n? So we deal here with the place values of a certain number. A number with 3 digits could be represented like this, ABC, okay, with a little hat here, so that here this would be the 10th digit, right? B. We don't know how much that is. Okay, so statement 1 says, when 10 times n is rounded to the nearest hundred, the 100th digit is 6. Okay, imagine a number, okay, with 3 digits, like for example, 235. You multiply by 0 or by 10, you just add 1 0, 2350. So, because of this, right, 10n can be represented like A, B, C, 0, all right? So, this way, we have our 10 times n. We round this to the nearest hundred. In this number, the nearest hundred is this. The 100 is B. So we need to check out what the value of this digit is. Depending on that digit's value, we could promote B up to 6, because the final result is A600. Being rounded, 100th digit is 6, and the rest just go away. It becomes 0. So here we have two possibilities. If C was greater than or equal to 5, then B should go up 1 unit. But if C was less than 5, then B remains. So we have two possibilities. Either B was 5 and it got promoted up to 6, or B was already 6. Okay? So we have from this, B should have been 5, and from this, B should have been 6. Two possibilities, not sufficient. Why? Because we don't know C. Okay? We don't know the digit C. We don't actually know anything about this number n. So, statement 2. Statement 2 says that 100 times n, that means 23,500. Imagine that would be, right, multiply 235 times 100. So here, 100 times n would be A, B, C with 2 zeros, right? Following. So, when this is rounded to the nearest 100, now the 100th position is this, C. So, it is rounded, and the 100th digit becomes 6. So, it would be something like AB 600. So here, you can see that this number, right, means that C was already 6. Why? Because for rounding 6, we need to check the number or the digit next to it. Next to its immediate right. But being 0, it means that C remains the same. Because if 0 is less than 5, then C remains. So this means C equals 6. But knowing that C equals 6 is not yet enough to know what's the value of B. B could be anything. So, as it's still unknown, it's not sufficient. Okay, so now let's move on to the last step. Combining the two statements together. Okay, we can reinterpret statement 1 by using information from statement 2. So we know that C digit, the units digit of n was already 6. Then the number 10 times n would have been AB60, right? And if AB60 got rounded to A600, so we know that because the digit to the right of B, the hundreds, this is the hundreds position, if this digit is greater than 5, so we know because of this that B goes up 1 and becomes 6. So from this, it follows that B must have been 5 originally. Now we have an answer, and that's sufficient. Option C. Okay? So to illustrate this, in statement 1, you could have had, for example, number, I don't know, 700, 570, and 7,618. Both would be rounded up a number such as 7,600. Both. Because here, because of the 7, 5 goes up 1. And here, because of the 1, 6 remains 6. So we have no way to know the original value of B, right? And so when we know for sure that the value is 6 for the second digit of this number, or the units digit of n, then now we know that it must have been something like this, for example, right? In this case, it could have been 560, something like this. When you round it, you get something like 7,600. Yes. Knowing this means everything.